Hi everyone, welcome back to my channel. So for today, we're going to learn about the ideal gas versus the real gas. So we're going to learn about the behavior of the ideal gas and also the behavior of the real gas. This is correspond to the learning outcomes for 5.1G and 5.1H. Okay, explain the ideal and non-ideal behavior of gases in terms of IMF and also the molecular volume. Explain the condition at which real gases approach the ideal behavior. Okay, so as I told you before, okay, in the first video, the ideal gas always follow the kinetic molecular theory. And also it always follow the ideal gas equation. So the ideal gas is the gas that obeys all the gas law. So that can follow Boyle's law, Charles' law, dan juga Avogadro's law. And also it will follow PV equal to nRT, the other gas equation, where we assume that the IMF ataupun attractive forces ataupun repulsive forces between the gas molecule is negligible, and also the volume of the gas molecules are negligible. This one, the IMF, why the IMF is negligible, I have already explained to you before. And also why the volume of the gas molecules is negligible, I also already explained to you before this. Okay, compared to the real gas. Real gas is the gas does not obey the ideal gas law, but it obey the Waals equation. Macam yang I dah beritahu sebelum ini, ideal gas is a hypothetical gas, but real gas is a gas that exists in reality. Okay, that's why real gas tak boleh nak follow up ideal gas equation. So, that's why real gas akan follow the Van der Waals equation. So, let's see the Van der Waals equation. P plus N square A over V times V minus MB equal to nRT. As you can see here, okay, it based kepada ideal gas equation with a minor correction here. Okay, as you can see pada volume kita ada minor correction. Okay, atas volume tu as you can see kita ada coefficient A, and also untuk the other volume kita V minus NB coefficient B. Okay, so this A and this B ada reason dia why it is there. Okay, so A measure how strongly the gas molecule attract one another. So from here we know that real gas adanya IMF interactions. Okay, dia ada attractive forces, dia ada repulsive forces. Okay, that's why we put the A coefficient there. Okay, and B measure of the finite volume occupied by the molecules. So it means the volume of the gaseous molecules in real gas is not negligible. So make sure you tahu A tu untuk corrected mistake apa, B tu untuk apa. Okay, sometimes question memang suka tanya A is for what, B is for what. Alright, so assumption ataupun characteristic of a real gas, IMF wujud between the gaseous molecules, and also the volume of the gaseous molecule is significant. Okay, volume dia tak negligible. When will real gas behave as ideal gas? Okay, so bila masanya real gas akan behave sebagai ideal? This one also a very popular questions. Alright, so real gas akan behave sebagai ideal pada high temperature and low pressure. Why pada high temperature? Why pada low pressure? So let's see the explanation. At high temperature, the average kinetic energy of the gas molecules increases because you supply the energy. Okay, so the gas molecules move faster and able to overcome the IMF between the gas molecules. So bila gas molecule kita bergerak dengan sangat-sangat laju, the kinetic energy is very very high. That's why dia boleh overcome the IMF. Okay, the intermolecular forces therefore kita akan assume as negligible. Hence the gas will behave ideally. Alright, and then what happen pada low pressure? So bila pada low pressure, untuk high temperature kita akan relatekan dia kenapa the IMF itu negligible, and pada low pressure bila real gas berada pada condition low pressure, the volume of the container is decreased. Okay, so low pressure kita tahu volume of container akan decrease. So the distance between gas molecules, okay, Oh, sorry. Bukan volume container decrease, increases. Okay. So, bila pressure decreases, katakanlah kita ada dalam satu container. So, this is our container. Okay. Kita reducekan the pressure. Okay, ini I punya ombor. So, this ombor akan provide pressure. Okay, so kita reducekan the pressure. As you can see, bila kita reducekan pressure, the volume of the container increases. Okay, so that's why the distance between the gas molecules are far apart. Compare kepada ini kalaulah kita low pressure, high volume. Kalaulah kita letak pada condition so, ini pada condition high P. Okay. Pada condition high P, okay, pada condition high P, as you can see here, the molecules, okay, akan berdekatan antara satu sama lain because the volume of the container to decrease. So, sekarang, macam mana real gas nak behave as an ideal gas adalah pada low pressure. Sebab pada low pressure, distance between gas molecules are far apart. Therefore, the volume occupied by the gas molecules is negligible since they occupy only a small fraction as compared to the volume of the container. So, sebenarnya, bila kita tengok volume occupied by the gas molecules tu, disebabkan volume container tu higher, okay, mungkin bahagian sini sahaja. Okay. Tapi sedangkan volume container tu besar. Okay. Therefore, the intermolecular forces between gas molecules are negligible because the distance between gas molecules are far apart. Therefore, dia punya IMF akan negligible. Alright. So, the gas molecule akan behave ideally. Okay. Now, let's see the condition when the real gas deviate from the ideal gas behavior. Jadi, pada condition apa yang real gas tak akan follow ideal gas behavior. Tadi, kalau dia nak follow ideal gas behavior, mesti pada high temperature dan low pressure. Okay, so when the real gas deviate from the ideal gas behavior, it means it happen pada low temperature and high pressure. Vice versa daripada condition tadi. So, bila low temperature, okay, kita reduce the supply of energy. Therefore, the average kinetic energy of gas molecule decreases. All the molecules are condensed and move slower. Therefore, they are closer to one another. Hence, they can form the IMF between the gas molecules. That's why the IMF between the gas molecules become significant. Hence, the gas molecule deviate from ideal gas. Kalau tadi ada gas behavior, IMF negligible. Now, pada low temperature, okay, the IMF akan become significant. That's why kita kata kondisi apabila real gas itu tidak memenuhi syarat-syarat ideal gas behavior. Okay. Condition yang kedua adalah pada high pressure. Pada high pressure, kita tahu the gas is compressed. As you can see from the diagram, pada high pressure, the gas is compressed. That's why the volume of the container to decrease. Hence, the gas molecules akan closer to each other. Therefore, the intermolecular forces between the gas molecules akan become significant because now when they are close to one another, they can form the IMF. Hence, the volume occupied by the gas molecules are significant since the gas molecules occupy a larger fraction as compared to the volume of the container. Sekarang ni gas molecule sudah memenuhi ruang disebabkan adanya ikatan antara diorang. So, the gas molecules deviate from ideal gas behavior at high pressure.
Okay, so let's see the correction for van der Waals forces. As you can see here, we adjust the measure pressure up. So here this one, okay, kita letak coefficient A ni untuk adjust the factor of intermolecular forces. So A constant to correct for intermolecular force between the gas particles. The value of A depends on strength of intermolecular force between the gas molecules. So value of A ini akan determinkan kekuatan intermolecular force. The smaller the A value, the weaker the intermolecular forces between the gas molecule. So kita tengok dekat sini, apa yang kita boleh kaitkan dengan Van der Waals equation. So when temperature decrease, we know that the average kinetic energy of the molecule decreases. Therefore the molecules tu akan bergerak dengan lebih slower, and then dia akan rapat-rapat antara satu sama lain. Dia akan closer to each other. Therefore the intermolecular forces between the gas molecules tu dia akan become significant. Bila intermolecular forces between the gas molecules become significant, hence these gas molecules akan kurang berlanggar dengan wall of the container. Berbeza dengan ideal gas. Kalau ideal gas kan dia tak ada IMF, so dia always collide with the wall of the container. Tapi untuk real gas, okay, dalam real gas bila adanya IMF, this cause dia punya collision, okay, dengan wall of container tu akan decrease. Therefore actually sebenarnya the pressure exerted by the real gas sebenarnya kurang daripada ideal gas disebabkan adanya IMF between the real gas molecules. Therefore the factor AN kuasa 2 over V kuasa 2 is added to the pressure term to correct the pressure of the real gas. Okay, disebabkan pressure of the real gas ini kurang daripada P ideal, that's why kita nak adjust the pressure itu bagi increase. Okay, that's why kita letak the factor AN kuasa 2 over V kuasa 2. Alright, and then let's see untuk adjust the volume pula. So adjust the measure volume down, factor of the molecular volume. So B is a constant representing the volume occupied by the gas molecule. The smaller the value of B, the smaller the volume occupied by the gas molecule. So lagi kecil nilai B, lagi kecil lah nilai volume of the gas molecules kita. As you can see here, ini ada volume of the container untuk ideal gas, tapi untuk real gas as you can see, okay, volume akan become significant. So at high pressure, the volume of the container decreases. So gas molecules akan much closer and volume of the gas molecules akan become significant. As a result, volume of real gas is greater than volume of ideal gas. So the space occupied by the molecule restrict the movement of the gas molecules. Hence must be subtracted from the total volume. So kenapa V tolak NB? Disebabkan adanya space occupied by the gas molecules pada real gas. Bila volume of the gas molecule become significant, okay, so kita tahu the exact volume of the gas tu dia mengambil ruang sebanyak mana. That's why kita subtract, okay, from the total volume. That's why kita total volume tolak NB itu. Okay, so the effective volume of the gas is not V, volume of the container, but become V tolak NB. Disebabkan apa? Volume of the gas is significant bagi real gas. So the factor NB is subtracted from the V terms to correct the volume of the gas which is larger than the ideal gas. Disebabkan volume tu significant, that's why kita buat correction of the volume. Okay, so as a result V real gas ni sebenarnya lebih besar daripada V ideal gas. Okay, disebabkan itulah bila pada keadaan high pressure, okay, volume tu akan become significant disebabkan gas molecule much closer to each other. So V container tolak dengan V gas. As you can see here, kita tolak dengan NB sebab kita nak adjust the volume down. Okay, kalau sebelum ni volume untuk ideal gas, as you can see here, kita assume volume tu mengambil, kita assume gas particles tu mengambil keseluruhan ruang dalam container kita. Sedangkan dalam real gas sebenarnya dia hanya ambil space yang sedikit sahaja. Alright, that's why kita kena tolak dengan NB. Okay, so and then bila kita combine both factors, ideal gas, and then kita combine dengan factor yang ada, so dapatlah Van der Waals equation as you can see here. So this one you can read the application of real gas equation. So A is a constant to correct the pressure by including the intermolecular attractive forces, while B is a constant to correct for volume occupied by the gas molecule. So A is a positive constant which depends on the strength of the attractive forces between the gas molecules. Okay, the smaller the value of A, the weaker the IMF. Okay, so the attractive forces of the gas molecule is not significant. Gas molecules akan behave ideally. So lagi besar value of A, it means the IMF akan become significant, jadi dia akan behave sebagai real gas. Lagi kecil value of A, therefore IMF become not significant, then the gas will behave ideally. Okay, so the value of A will determine whether your gas will behave ideally or whether your gas will behave as a real gas. Alright, the same goes to B. Okay, so the smaller the value B, the smaller volume occupied by gas molecules. Okay, then the gas molecule akan behave ideally. So the larger the value of B, the larger the volume occupied by the gas molecules. Therefore, the volume akan become significant. The gas behave more like real gas. So make sure you tahu apa applications untuk constant A, apa application untuk constant B. Okay, what happen when constant A higher, what happen when constant B higher. Okay, make sure you know these things. Okay, so read again and again, make sure you understand.